Okay, so let's look at number 4. It says a baseball player swings the bat and makes contact with the baseball at a height of 3 feet. Very important right now. This right here is going to be 3 feet. And then it says with an initial velocity of 190 feet per second. So let's say that its initial velocity is that magnitude per se that we know with the equation. So it's like magnitude cosine of t and so on and so forth, and then magnitude sine of t minus 16t squared plus our initial height. We know that as our x and y parameters. Okay, so this velocity of 190 feet per second, we're going to put right here as far as those values are concerned. Okay, the initial height, it said, was 3 feet. That's going to be over here in that y parametric equation. And with an angle, let's do this in gray, of 12 degrees. That's going to be here and here. And it also will go for t right here. Okay? Actually, hold on just a bit. I actually don't. It's not there. Let me change something real quick. No worries. We could use this as a teachable moment. It's going to be cosine of theta. Sine of theta. And then it's multiplied here by t, multiplied by t, minus 16t squared plus h. There we go. So this is going to be gray for the angle of 12 degrees here. So what we're going to do is we're going to write the parametric with all these pieces out and see what we get. So for x, we're going to have the magnitude, which is 190. It's going to be multiplied with the cosine of the angle, which is 12 degrees, and then it's going to be multiplied with the time. So we're just going to put t for now. And then y, it's going to be 190 also, and it's going to be multiplied by the sine, because sine is y and cosine is x, of 12 degrees, and then it's multiplied with t minus 16t squared plus 3. Don't forget your initial height of 3, just like we showed from above. So the outfield fence is 450 feet away. So this distance from where contact was made all the way to this fence is 450 feet away. Okay? After how many seconds will the ball reach the fence? So we want to know how many seconds will it take until it gets all the way over there whenever it starts from a height of 3 feet. Okay? So let's go ahead and work this out. First of all, what we need to do is we need to figure out this time, this t that we're looking for. Okay? And if it's 450 feet away, we know that's a horizontal distance that we've recognized as x. So 450, we're going to set it equal to this 190 cosine of 12 degrees times t. And we're going to solve for each of this. Okay, so we're going to do solve. Let's go for n solve. And we're going to do comma t. So remember, when you do this solve feature here, you always have to tell it which variable to solve for. And it's going to do all the legwork for you and give you that t value. Okay, so we want to see how many seconds would it, first of all, take for the outfield fence to basically reach the fence. We're not saying whenever it touches the floor, okay? Because it could do this, or it could hit the fence, or it could go over, and we're not trying to see when will it hit the ground, like if it were to come all the way over here. We're not saying where it hit the ground. We're saying when will it reach the fence. In other words, imagine this huge vertical line, and basically, when will it reach and hit this vertical line? Whether it's the fence, whether it's below the fence, whether it's above the fence, wherever, we're trying to see when will it reach that vertical line per se of that 450 feet. Okay, so we've set our x parametric equation to it. Now we're going to go to the calculator, and we're just going to solve for t. All right, so let's go ahead and go to the calculator. And we're going to say 450, menu 3, 1 for solve, 6 for numeric solve. So let's do menu 3, 6. and we're going to do 450 is equal to, so 450 is equal to, and it's going to be that x parameter that we had from up top, which was the 190 cosine of 12, okay? So 190 times the cosine of 12 degrees. Now you can put degrees if you want, but if you notice at the top right hand corner, I've already set my calculator to degree mode. Okay, so you see it right here. Okay, I've set it to degree mode, and in case yours is not, you can always trump it with putting a degree symbol there. Okay, so let's say it was still in radian mode here. If you put degrees here, it will still put it as far as calculate it that way. Otherwise, just press home 52, set this to degrees, then scroll up to make it your default, and then press 4 to go back to your current document. And you'll see at the top right hand corner, you do in fact have degrees. Either way will work, okay? So let's go ahead and go to, let's go back to our equation, and we're going to do times t, and then comma t. So times t, comma t, and then control enter. And we see that it's going to take 2.421 seconds. So we're going to say time is 2.421 seconds. And we just wanted to know how long would it take to reach at that point. So on the test, most likely you're going to have 3 decimal places. So that's where we're going to put 2.421. Now let's go to C. It says if the fence is 12 feet tall, so this 12 feet tall is right here, will the ball go over the fence? So we want to ask ourselves, will it actually go over the fence? So what we need to do is we need to see the keyword is at 450 feet, which is the same as saying what we just found, at time is equal to 2.421. We want to see how high is the ball. Okay? So we know it took this many seconds to travel this 450 feet that we were looking at to reach the fence. And now when I use this t value, I can use it in the y parametric function to see how high will it be at those 2.421 seconds. Okay, so let's go ahead and go to our y parametric function, and we're going to plug in this t value of 2.421. Okay, now I teach my students that as you are inputting numbers, like we just answered this part B, and you notice that I rounded to 3 decimal places. But if I'm going to use this for part C, I'm going to unround basically, and I'm going to unround back to at least 6 decimal places. And then whenever I get my answer, I'm going to write my answer back in 3 decimal places. Okay, so let's use from part B, we're going to unround that, and we had 2.421.333. This is what I'm going to use to plug into my y parametric equation, so that when I plug this t value, let me highlight it in gray, when I plug in this t value here and here for t, all of this is going to give me what is this y value going to be? What is that height going to be? Because then we can determine, did it in fact go over this 12 feet or foot fence, or did it hit below? Okay, so let's go ahead and start plugging that into our calculator. Okay, so we're going to do 190 times the sine, and it's going to be 12. We don't have to put the degrees because it's in degree mode. And then it's going to be multiplied by, and I can just go up here and press enter. That's my t value. And then it's going to be minus, go up here, press enter, t squared. And then it's going to be kick down, sorry, 16t squared. I forgot the 16. Let me input that in right here real quick. So 16t squared, and then we're going to do plus 3 at the very, very end. Then control enter, and you see that when it reaches there, it's going to be at a height of, what does it look like? 4.845. Okay, so 4.845. So the y value at this time is going to equal, from my parametric equation, a height of 4.845. And I'm rounding that back to 3 decimal places, so instead of 8.44798, it'll be 845. And this is going to be feet. So obviously, guys, this is not high enough. It's going to hit like down here somewhere, because it's like 1/3 of the way of this 12-foot fence. So it's not going to, in fact, go over. And the explanation that you can say is that when it reaches the 450 feet away at that 2.421333 seconds, that it's going to be only 4.845 feet off the ground. It's not high enough to clear the fence. So you would write all that in words. Okay.